the kind of interactive sessions. I want to see, you guys questions from you guys, and um, if you don't talk, we don't understand whether you're really getting it, and we want kind of interactive session. This kind of we want to see in a classroom kind of environment, even though you don't see the instructors, but as it is everything available for you guys, pencil, whiteboard, and everything available. Okay, Raghavendra, I'm giving you control and you take it from here.
Okay, thank you, President. Okay, good morning everyone, and my name is Raghavendra, and I have experience in .NET for almost 10 years, and I have been working in a different industry practices like telecommunications and high tech and the finance and banking and insurance sector. So today I'm going to be our instructor for this .NET course. So as we are starting, today is our day one, and we are going to talk about what is .NET and why the .NET is evolved into the market, and what is the need for the .NET to come into the market, and what other languages that were there before .NET, and how it changed the whole development scenario once the .NET comes into the market. So before going to that, I just wanted to give some introduction about the logistics, that how can we talk, and if you have any questions, how can you raise it. So if you see the WebEx, right, you have different options where you can
sorry to interrupt you. Before you start, can you have individual give the introduction about themselves?
Sure, Prasad. Yeah, I can. We can go one by one, Prasad. Yeah.
Yeah. Can you start speaking? This Amica user. Just give introduction about yourself. What is your background? Where are you from? Your location.
Hi, my name is Anshul, and I'm just joining for today to see if I have something to learn from this training. And I live in Phoenix area.
Okay, is this Anshul, right?
Anshul.
Okay.
Anshul, okay. Do you have any prior experience in any other technology or anything?
I have C++ experience.
Oh, okay, that's good. Okay. Okay, can we go ahead with the other?
Archana, can you talk, please? Yeah, you can speak now. We cannot able to hear you. You muted yourself. Yeah, now you can talk.
We are not able to hear you, Archana. Archana, are you talking?
Can you hear our voice? Yeah, Archana, do you have any problem in talking, or what is the issue? You can tell me in the chat. Yeah, we can hear you now.
Yeah, I am Archana and I'm from Phoenix.
Okay, can you give your background, please?
I'm on right now. I'm on S4 and I'm looking for a job. And I have experience in C++ in India.
Okay, good. Calling user 4, can you talk please? Can you give brief introduction about yourself? Arnab is another instructor, so you want to go to the calling user 4. Can you speak please, calling user 4? Hello?
Calling user. I think he has joined on the phone actually.
You can talk still, right?
Yeah.
I think in the phone also you can talk. Colin, otherwise you can chat in the, you can type in the chat if you are unable to talk.
Calling user.
Yeah, I'm not sure there is a test, but okay, we'll pass it to, next guy. We create, Arnab is another instructor actually. So, want to move to, cricket there. So, I'm sorry, if I apologize that, if I spell your pronouns wrongly. Can you speak please little bit? Hello? Okay, we'll go to Shekhar. Hey, Shekhar, looks like you had a question also. So, go ahead and, give the introduction about yourself and,
This is Shekhar. I'm calling from Missouri, St. Louis area.
give,
Actually, I'm looking at, the others are like, they are in speakerphone, but I'm unable to hear only my through computer. I'm only connected through telephone.
you have to, if you see on the, WebEx window, there is an audio button, make presenter and audio button in the participant list. If you click that audio button, it will open the, use computer microphone option. So looks like you choose the,
Okay.
option. You need to choose a microphone audio option.
Okay, fine. Got it.
Yeah. Would you like to, give introduction about yourself? Hello?
Oh.
Yeah, go ahead and speak. Yeah.
Oh, hi. My name is Patricia and I live in the Tempe area. I have a bachelor's in management information system and I have some experience with VB, C++, Java, HTML, and CSS and NSC. And I joined this class to have an understanding of how the network environment works. The Dotnet environment works. I'm sorry.
Okay, thank you.
Thank you.
Okay, let's go to Sija. Sija, would you please give the introduction about yourself? Sija? Sija? Then Sirisha, can you hear us?
I think Shirisha didn't join in the call itself. No, it's not showing any
She
call
doesn't
icon.
look like, she didn't turn on the, microphone or speakerphone. Calling user, would you please talk one more time at least, we want to know who you are. We are really struggling. Please help us, Yes, Sirisha,
Okay.
can you give introduction about yourself, Sirisha?
Yeah, sure. Hi, everyone. I'm Sarisha. I'm located from Atlanta. And coming to my experience, I have 3.5 years of experience in .NET development. I worked in 2005 version. I worked in the web forms, the UI development mainly, and also have experience in the web services and XML. I worked in the mortgage and banking domain. Worked for Bank of America actually for 3 years. And presently I'm on H4 and I'm looking for a job opportunity.
Thank you, Sirisha. Yes, CJ, would you like to give introduction? Oh, okay. Yeah, that is fine, CJ. Look like she had some problem. That's fine. Actually, you have to change your. Look like you are joined on the phone. You can join with the microphone if you would like. In the participant list, in the middle, you see make a presenter audio. Click on that audio. Change it to your preferences to attend from the computer microphone. But you can hear us, right? Okay, that's fine. You can tell about yourself in the chat for everybody. Instead of just you choose only me privately, yeah, you can tell everybody. Just right. Thank you, Sija, and probably this training will give you some technical information, and somewhere you can start exploring your technical skills. Okay. Thank you, guys, and Raghav, I think you can now start.
Okay. Thank you, Prasad. Hi, everyone. Yeah, actually, it's like we have a mix of people. Shekhar, do you want to say something? Okay. Yeah, it looks like we have a mixed set of people. Like somebody has experience in C++, somebody has experience already in .NET, somebody comes from the management background, just like that. Okay. As much as possible, I would like to concentrate the training so that it covers and it fulfills everyone's needs in this training. So, and today we are going to talk about the .NET background and the overview of the .NET. So, as I was saying, if anybody want to have any question at any point of time during the course, you can put a question in the chat window, or you can unmute your mic and you can raise a question also. So either way is fine. So, but we would like to have this more in an interactive way rather than I'm speaking and you are listening. So now let's go and see the agenda of the today's training.
Hey, Raghav, this is Anshul.
Yes, Anshu.
I'm wondering what kind of coursework we are gonna handle as we progress in the course. So how is that gonna happen? We haven't talked about that. Like, there's training and then there'll be some classwork as well, I believe, right?
Correct. Actually, yes, that's correct. So today I'm going to give the demo of the basic, the Hello World program in the .NET. But from tomorrow onwards, we are going to give you a labs as well. So probably I'm going to explain a theoretical session and I'm going to I'm going to demonstrate one program. After that, I will provide you some labs on the topics that we have discussed on that particular day. So you can practice that labs in the class itself, or you can do offline also. And if you have any questions, you can ask the questions in the next class.
Okay.
So, but there will be definitely labs that will be provided to you, Anshu.
Okay.
And today I'm going to explain you like what do you need to practice the labs and what kind of version, what kind of edition that you need to install, how you can get that Visual Studio into your machine. So all those I'm going to talk today. Okay, let us go and see our agenda for today. So today we are going to talk about the overview of the .NET framework and how it is different from the traditional programming languages like C, C++, or VB components that are present in the .NET like CLR, CLS, CTS, like what is assemblies, what is MSIL, all these kind of things that we are going to, what are the, what do you mean by namespaces, right? The framework class libraries. So finally, we are going to talk about the Visual Studio, which is the ID, the integrated development environment for developing the applications in .NET using any language. So we are going to talk about Visual Studio, how to install it, where we can install. So is it a free edition or is it going to be a paid edition? All these things that we are going to talk today. So now let's talk about the .NET. So why .NET? So how it came into the market? Why do we need the .NET? What is in the market before .NET? So .NET, before .NET, we used to have a languages like C, C++, all that kind of languages. So what are those languages and how .NET is different from that languages? So as you see, the C and C++ languages are like mostly like a modular programming languages with a small exception to the C++. C++ supports object-oriented as well, unlike C language, right? So before .NET, like this C, C++ is mostly supports like a programming, modular programming. It's like a you just have to write a program with hundreds and hundreds of lines of code. So you with just a limited level of modulation, with limited reusability, right? So there used to be no inheritance, no support for inheritance, no support for any abstraction, all that kind of things are there. So mostly like reusability, no interoperability between the languages, right? No platform independence, all that kind of problems that we used to have in the C language. But rather, yeah, it has got its own advantages in the C language, but again, it has got its own disadvantages. So based on that disadvantages, so Microsoft has come up with a new framework called .NET, purely based on the concepts of object-oriented programming and overcoming the advantages, the disadvantages that we are having in C and C++, that kind of languages. So when before .NET, we used to have something called like a component object modules. right? So even with that also, we were able to achieve a limited interoperability, like whatever the components that we have developed in VB, we can very well use it in the C++ or the C++, but not up to the level that .NET supports, right? So thus from a paradigm where applications replicated code to provide common services, so and we have moved to a paradigm where applications are built as a collaborative units of components working together. So what does this mean? This is like a simple shift just see, when we want to reuse anything in the C or C++, what we need to do is we have to just replicate that code. What we need to do, if there is anything that a code snippet that is available in C, we just copy that and paste it in our own program. So because there is no reusability, very easily reusability that you can use from the C or C++. But in the .NET, what we can do is we don't need to copy or we don't need to replicate anything. So rather we can extend the available functionality or we can reuse the available functionality as it is. So that is how we are moving from the replicated code to the collaborative units of components. So this is like a model where applications can be built as reusable components and are shareable over the internet. So how we can share that over the internet is through the forms of web services or some other web applications, all those things. So, and this is .NET is a model that encourage applications to be shared as a service. So that is like a read as a web service as again. And this .NET enables like true interoperability wherein the language used is only a matter of choice. It's up to you that what language that you want to develop an application in .NET. You can use different languages like VB, C++, C#, VC++, F#, all that kind of languages that you can use it in .NET. So actually the .NET is not a language. It's not a tool or it's not like a product or something. It's a framework, it's a new computing platform developed by Microsoft that simplifies application development in the highly distributed environment over the internet. So before this .NET or Java, right, we never used to have so many applications or so many services that were available in internet. So all C and C++ applications are like a standalone applications which used to run in a one machine, right? So when it comes to the distributed environment, it's like, okay, develop once and distribute it everywhere like that. So that's where we need a good kind of framework which supports this distributed development. So that's where .NET coming to the picture, which supports this distributed environment to develop the application, which supports for the multiple targets like multiple target audience like internet or standalone applications or any services or TCP/IP remoting, all that kind of things. So what is what is .NET? .NET has been developed to cater to the following objectives and requirements. So though C++ supports object-oriented programming, but the C++ is not a complete object-oriented language. But any language in .NET is a complete object-oriented language. So what does that mean? So in .NET, if you want to write any program, you have to write that particular program in a class or you need to create that as an object. So you cannot write a standalone piece of code where you can execute it like in a C++. C++, you can just open a program and you can write something in a main method and it will create a program. So that is, you don't need to write any class or you don't need to write any or create any object if you want to execute anything, right? Which is not the case in the .NET. If you want to write any single line of code also, you have to write that you have to create a class, in class you have to create a method, right? That is why it is completely like object-oriented language, .NET. So, and in C or C++, right? So you used to have like a lot of memory leaks if you don't take care of memory properly, right? So that was the one disadvantages in C or C++ languages. So where in the .NET, Microsoft has overcome with that disadvantage, saying that okay, it provides a code execution environment which is very safe actually here. So, and deployment also, it simplifies deployment and versioning, right? So in C++ arena, if you deploy something, if you create one executable, right? If you want to modify anything, you need to override the existing one. So you cannot have two versions of executables at same location at same time it's running, right? So that kind of problems, the .NET removes that kind of problem. So it executes that, it provides the execution environment, and it guarantees the safety of the code that it is executing. So like, let us say your code is executing in one process, right? So what does it mean? What is the safety of code means? Right? In C or C++, even though your code is executing in one process, but there used to be some scenarios where the other programs executing in other process used to interact within the another process which is like outside of your own program process, right? So that is means like okay, some kind of you need to have some kind of pointers that you are accessing, right? So by mistake, if you read some data which is present in the other process, so that becomes like a very memory conflicts, all that kind of error you used to get it. So, but in .NET, right, you don't directly deal with the memory. So you just always directly deal with the objects and the data that is provided, that is present in the objects. So in that case, the reading the pointers and the creating the pointers, it's all taken care by the .NET in the background. You don't need to create any pointers. You don't need to read any data by using the pointers like in C or C++ in .NET. So that's all taken care by .NET in the background. So that is why the .NET provides you the guarantee for the safety of your code and the data. So this .NET includes both the safety of the code, right? Includes both the code developed internally in your program or the code developed by third-party vendor. Let us say in your program, if you are accessing or if you are referencing any other DLL or any other code that was developed by another product or another tool, right? Even that code also will be guaranteed. The safety of that third-party code also will be guaranteed by your .NET environment. But here there is one point here. That third-party the code also should also be developed in your .NET only. So if it was developed in again a C or C++, there is again like a something called you need to create an unsafe environment in your .NET program itself, wherein your C or C++ piece of code will execute in that unsafe mode. So that kind of guarantee that .NET cannot provide because that was native to the C or C++ language itself. So to provide the code execution environment that eliminates the issues faced by the scripted environments with respect to the performance. So the scripted environments here like before VB script or JavaScript, right? So whatever the code that you write in the scripts by using scripts like JavaScript or VB script, right? Even for that also .NET provides the environment, the execution environment. So they're also used to face like, okay, some kind of script errors that we used to get, right? So that errors also the .NET will take care of in the .NET environment. So here again, to provide a common programming model where the choice of programming language becomes a matter of choice. So it gives the like almost 25 to 26 languages wherein you can choose based on your competence. Like if you have a VB experience before coming to .NET, you can choose VB.NET. If you are familiar with C++ kind of syntaxes, you can choose C#.NET here. So if you are so familiar with VC++, you can choose VC++.NET and .NET. So there are like different languages based on their experience, based on their familiarity, right? So they can choose their own language in .NET. So basically, .NET comes with a two major components. One is called the common language runtime, and the another one is like a framework class library. So any doubts so far? Okay. Now we'll talk about the .NET framework. So this is the diagram that shows or that talks about the .NET framework. What all the components that comprises of .NET framework. So or where exactly in your machine your .NET applies. So if you see at the base of this diagram, right? So if you consider your whole machine as right, at the base, if you see in this diagram, it is like an operating system is present, which can be like any platform, operating system like Windows, Linux, Unix, right? So it can be any platform which is required for executing any of your program, right? So after that, the next level, the next component is like a CLR. If anybody is well aware of the Java, right, the CLR is equivalent to the JVM in Java, the Java virtual machine, what is called in Java. Here it is called CLR, the Common Language Runtime. So the CLR is the subset and that abstracts the underlying operating system from your code. So if you have a CLR, so the CLR is the heart of the .NET, which understands your .NET code and which converts that code into the machine level understandable code. So this CLR, right, even though I'm saying here it is CLR, the CLR is used to be like if you are running, the CLR is like you have Windows CLR, and the same CLR will not work for Linux. Linux will have its own CLR, or Unix will have its own CLR, right? So on top of that, you have something called the base class library. So this is what is called, I'm talking about the framework class library and the base class library. Both are the same. This base class library provides or it contains types, interfaces, classes, structures that all comes by default with the .NET framework provided by Microsoft. So it contains lot of APIs, base APIs which are required for your common tasks like string operations, file operations, right? So console input output operations, all these kind of operations that comes as an API in this base class library. On top of that, you have another component called ADO.NET and XML. So in the next sections, we will talk about the ADO.NET is like an active data object which deals with the backend databases like the SQL Server or Oracle. It provides again is an API which used to connect to or which used to work with the databases like SQL Server, Oracle, or any kind of databases. So again, XML. XML is like a extensible markup language. This is again here you will get a lot of API which you can use to create the XML document, or which you can parse the XML document, which you can write the export expressions, right, to extract some piece of data in the whole XML document. On top of that, here you have two parts actually. One is Windows Forms, and another one is like a set of web. These three things are called as web: ASP.NET, Web Forms, and Web Services. So what is Windows Forms? Windows Forms is like a standalone application, standalone Windows which runs on the your machine. It's like if you say Yahoo Messenger. Yahoo Messenger is a Windows form which runs on your machine, but it connects to the Yahoo web server, all those things. But as an application, it is called as a Windows Forms application. So ASP.NET. ASP.NET is again a language which used to create web services or web applications or web forms or websites in the .NET area. So web forms is like any form that you fill it on the web. Let us say student application form or a bank account opening form or something. All these calls like a web form. Any web page you can call it as a web form. Web services. So web services again is a piece of code that you expose it to the public over internet. That is called a web services. So we'll talk more about this in detail in the subsequent classes. On top of this, common language specifications, so which talks about the specifications that contain how to deal with the different languages before processing that to the CLR. So on top of that, you have a C#, VB.NET, C++, J#, and so many other languages like F#, all those kind of things are there. So we'll go to the next slide. We'll talk more detail about common language runtime here. So what is common language runtime? So the CLR is the platform. It's a platform actually on which applications are hosted and executed. So whatever the code, whatever the application, either it could be web form or ASP.NET website or a web services or Windows Forms, right? These are all, we call it as an applications, right? And we host these applications is a platform called CLR, and the CLR is the one which executes these all applications. So the CLR also provides a set of services that applications can use to access various resources. So it provides like a set of services or API to access various resources like arrays, collections, operating system folders like Windows folder or system folders, right? So because this CLR manages the execution of your code, right? Code that works on CLR is called as a manage. So we call something like here one keyword that we have it in .NET, we call it as a managed code. So what do you mean by managed code? So whatever the code that we write to target to execute on CLR, right, is called as a managed code. So what is managed? Managed code means whatever the application that you create, right? So these all the things like memory management, thread management, or whatever the as I'm talking about the pointer or object creation, right? These all will be taken care by CLR automatically. You don't need to do anything explicitly for you to create any pointers or anything like that. So since this runtime manages all these execution of your code, allocating the objects, right? So that is why the code that works on the CLR, whatever the code that we write, right, this works or this executes on the CLR. That's why we call this as a managed code. Any code that you write which is not targeted to run on CLR is called unmanaged code. So as I was telling that if you are referencing any C or C++ program in your .NET, so that will obviously be executed using C or C++ compiler or that environment. That is called like an unmanaged code. So we'll create that in an unsafe environment in the .NET program itself. So wherein your C++ component will execute. So what is the .NET CLR framework provides, or what it manages? So it manages your code execution at runtime. It manages memory management. It manages thread. It manages remoting. Remoting is like another area in .NET wherein you used to connect to different systems using different kind of technologies like TCP/IP, HTTP, any channel like SNMP, SMTP protocol, which you use different types of protocols. So that is called remoting. So again, here we are the ensuring type safety. It also manages the type safety. So the CLR is the platform on which your applications are hosted and executed. So it provides basically a platform for your applications to be hosted and execution. The following are some of the benefits of the CLR, like performance improvements, the ability to use components developed in other languages. So here, like, you are writing your preferred choice is C#, right? And you are creating one program. But if you want to use something that was developed in a VB.NET, you can very well use that in your C# program. So you don't need to put a lot of effort in using VB.NET component in your C# program, right? So that is the interoperability, that is the language interoperability that CLR or the .NET provides. So how it is managed to run between different languages, that I will explain in the next slide. So extensible types provided by a class library. The .NET by default provides like hundreds of APIs which will take care of the very basic functionality that is required. So which was not the case in C or C++ languages. Wherein in C language, if you want to do any string operations, you need to write a lot of code for that. But here in .NET provided a lot of methods, a lot of APIs. You can just you can use out of the box those functions. So new language features such as I was telling these are all the object-oriented principles like inheritance, interfaces, right, and overloading for object-oriented programming, and support for explicit free threading that allows the creation of multi-threaded scalable applications, and support for structured exception handling and custom attributes. So in C and C++ languages, it was almost impossible to create a multi-threaded program. Yeah, you were still able to create it, but it was too difficult to create a multi-threaded programs in C++. So, but in here in .NET, it's very easy to create the multi-threaded programs, and you can scale your applications very easily to meet the growing demand or to meet the growing volume of your requests for web services or web requests. So this is what is I'm talking about the language interoperability. So what is the language interoperability? So as I was saying, right, the ability of the code, that is your C# code, to interact with the code that is written using a different programming language, that is VB.NET. So language interoperability can help maximize code reuse. So what is the use of that? Here, if you are using that VB.NET, so that increases your reusability of the VB.NET code. You don't need to write that same thing in C#, or you don't need to replicate the same code in C#. So rather, you can directly go and reuse that which was developed in VB.NET. So that improve the efficiency of the development process, and it reduces the development time also. So, and again, it's very easy to use something that was developed in a different language. So how it is possible, right? So in what way it is possible? So that is possible because of the concept called Microsoft Intermediate Language. So that is called as shortly MSIL. So So MSIL is the CPU independent instruction set into which .NET framework programs are compiled. So what happens is you write a program in C#, right? Here two things that you need to understand here. So one is called a compiler. So compiler is a program which converts your code into uh, into the into assembly language, right? So but in C#, in C++ or in C language, what you call a compiler is a program which converts your human readable language to the machine level language, machine understandable language. So that is what we used to tell in terms of C++ or C language. But here, Microsoft, what they have brought the concept like an intermediate language. In between this human readable language and machine level language, they introduced the one concept called intermediate language. So they have actually divided the full compilation process into two parts. One is like they are calling it as a compilation, and another one they are calling it as an execution. So what compilation means is that your compiler converts your source code, which was written in any language like C#, VB.NET, or whatever the VC++.NET. Here, that's why I mentioned it is a language compiler. In .NET, you have a different language compiler. So for VB.NET, you have a compiler called VBC.exe. That is like a VB compiler. For C# programs, you have a different compiler called C# compiler, CSC.exe. Like that, a J# compiler is there, F# compiler is there, right? So for each language, you have a own compiler, which converts its own language, its own source code to two different parts here. Like one is code and another one is like a metadata. So what is code again? Code means here is again like a intermediate language. So it's again in a different format of language which the compiler converts your source code. So any compiler here, how it is possible, right? Let us say any compiler, whatever the code, no matter in what language that you write it, and no matter what language compiler that you are using, the output will be always same only. Right? You understand, right? When you write a program in C#, right, and when you compile that code, your output is always same, irrespective of your language, right? So this IL will be always same regardless of your language. So that is just a compiler part, basically. So far we have not executed any code. So far we have not used any code. We have just written a code and we have compiled that into a intermediate form. So now, when you want to execute a code, let us say you have created a program, you have a .exe file, right? So you have not invoked that exe file. So now you are going to invoke the .exe file. What happens? So what you are invoking here is a intermediate language only, but not your source code. In fact, right? You have written a source code and you have compiled and you made it as a intermediate language with metadata. When you are invoking, what you are invoking here is a IL. So this IL is always same regardless of your C# or VB.NET, right? When you invoke the IL, the intermediate language, there is something other called as a JIT compiler. So what is this JIT compiler does? JIT compiler, what is JIT means? Just in time. So what this JIT compiler does is, when you invoke that program, right, it will take that IL code, the intermediate language code, and it will convert that. See, so far your intermediate language, your operating system, or it's not like a machine readable language. So this is the JIT compiler is the one which converts your intermediate language into machine readable format. So obviously your operating system doesn't understand your intermediate language. Operating system only understands the assembly language, like the instruction set that you used to write it in 8086 language, all that kind of stuff. So this is the JIT compiler is the one which converts the intermediate language into the native code. Native code means whatever the operating system where you are running your program. So if it is a Linux, it converts the Linux instruction set. If it is a Windows, it converts the Windows instruction set. So that is why I said the CLR is the one which is targeted for the different operating systems. So in this way, Microsoft achieved that language interoperability and at the same time the platform independence of your code, whatever that you are writing. So, but here, right, when you are writing the code, you don't need to bother about, when you are writing code here, right, you don't need to bother about the target platform, where it is going to execute, whether it is going to execute on Windows or whether it is going to execute on Linux, or it doesn't matter actually. So, you just have to take this IL code and deploy it in whatever the operating system that you want. But whenever the JIT compiler comes into the place, right, it is the one, it has to be targeted to the particular platform, either it is Windows or Linux. So this is how Microsoft has achieved the language interoperability and the platform independence. So any questions so far? Okay.
I have one actually.
Sure.
Yeah,
Okay.
sure.
Yeah, tell me.
So, what is the reason of taking this abstraction to a level just before the machine? Like in all other traditional languages, right, they were directly executing at the machine level. The compilers were translating the code into machine code, and it was being executed.
Yes.
I understand that it was difficult to target it to multiple platforms. But what did Microsoft gain by introducing this additional level of abstraction in here?
Correct. Right. One advantage of this language interoperability is, right, let us say people who have been working in VB, so for them to move to the C# syntax or C++ syntax is very difficult. So let us say what happens is whenever I am executing one project in a real-time scenario, right? I have a developers who are working on VB and somebody is working on VB and somebody is working on C++ or C language, right? So they have been working for the last 4 or 5 years, right? Now I want to get the .NET into my organization, into my project, right? So if I don't come up with this kind of language interoperability, right? If I stick to only one language like C++ or whatever the VB or whatever the language, right? Now, what I need to do is I need to move all these developers who are in the mixed background to one language, which is very much time consuming and expensive as well, right? People who are on C++ is very much familiar with the C++ format, but people who have been working in VB and if we ask them to move to the C++, it's again difficult, time consuming, right? So, for the organization.
My question is, up to the metadata part, I understand that it's easy for all the developers with the different streams to come on a single page, right?
Correct.
That's fine, right? But the thing is, we could have a stack, like right from the language, like human readable language, all the way down to the machine language, and not bother converting it into that intermediate, because that's what the traditional programming model was, right?
Correct. Yeah. See, now, why Microsoft has come up with this, right? So when people are saying this Java is platform independent, Java can run on Linux or Java can run on Windows, right?
Yeah.
Right. So, but before Java, whatever the languages that Microsoft has like VB or C++ or C, right? So VB used to be run only on Windows environment, right? So you cannot execute VB programs on Linux environment. Do you? Right?
And
we cannot. Yeah.
Okay. Well, my question was like, because, typically a compiler would be translating into the machine language, right? And the machine...
That's correct. See, okay, let us say if you remove the intermediate language, right? Now I am writing source code, right? So now I need to know before you are telling, see, when I am converting source code directly to the machine code, right? So I need to know and I need to take my target platform into consideration. if only one platform,
True.
right?
Mm-hmm.
So, but if I want to remove that restriction, if I want to write the code which can work on different platforms like Linux or Java, or Windows, any kind of platform, right?
Mm-hmm.
So then I need to have something kind of intermediate. So wherein that intermediate will form as a base for any kind of platform.
So does the current .NET programs work on Linux as such? No, right?
Yes, it will work.
So I believe there is a Mono framework for Linux and all that, right?
Yeah, that is what Mono. Mono is not a framework. Mono is like a CLR actually. See,
Yeah.
what Microsoft tells is Microsoft has created a CLR for Windows platform, right?
Okay.
But at the same time, they have allowed the other companies to develop a CLR for their own environments also. But as such, Microsoft has not come up with a CLR for Linux environment. So very novel company, right? Novel has come up with a CLR called Mono, which is for Linux environment. But the source code that you are writing, right, can directly execute on the Linux by using Mono CLR.
Okay.
So you don't need to write a separate code for executing that on Mono.
That's right.
Okay. This is language interoperability, and then next thing is the common type specifications. So common type specification, what is this common type specification? It's a component in .NET framework. So the CTS represents the data types of different languages in a specific format specification. So like how types are declared, let us say how the integer has to be declared, how the boolean has to be declared, different types of data types, characters, strings, all these things. And this different and managed in the common language runtime. So basically, it also forms as a base for the support of cross-language integration. What we are saying is as like MSI and the Microsoft Intermediate Language. So the common type system performs the following functions, like establishes a framework that helps enable the cross-language integration and type safety and high performance code execution. So, and to provide an object-oriented model that supports complete implementation of many programming languages, like it tells us that it's like a specification. It tells us that how you can declare your own data types, how you can use the data types that comes by default with Microsoft, right? So it defines basically rules that languages must follow. As I was saying, right, the .NET comes with different languages like C#, C++, VB.NET, right? You also can write your own language. That means you also can write your own compiler, which targets to a .NET, right? By following the specifications given in this common type system. So this common type system is common across all languages that was provided by Microsoft. So basically the specifications are common, whether it is in Java in C# or .NET. So it just gives the different types of rules, and the common type system supports like two general categories. One is Uh, yeah, yeah, Anshu, if you are not talking, you can go on mute, please.
I'm sorry.
Yes, no problem. Thank you. There are like two general categories that comes in this common types. One is value types and another one is like a reference types. So this value types directly contains data, and instances of the value types either they are allocated on the stack or allocated inline in a structure. It's not directly referenced by a pointer or something like that. If you take in the C or C++ language terms, it's like an integer or a double something like. If it is a reference type, it is just like a pointer to a variable or pointer to some data. That is called a reference type here. It stores a reference to the value's memory address, but these are all allocated on the heap. Whereas value types are allocated on the stack, but whereas the reference types are allocated on the heap. So these reference types like can be a self-describing types, a pointer types, or interface types. So we will talk more about these value types and reference types in the next class when we are discussing about the data types, all those things. But the primitive data types that comes with this common type system is Boolean, byte, character, or int 32. That's like a 32-bit integer. If it is like a int 64, int means unsigned integer, which are used in the application development. We'll go to the next here. Okay, the next thing that we need to understand in .NET is .NET assembly. So what is this assembly? So an assembly can be anything like, okay, when you are writing a program, right? So you have to compile that program and you need to create some kind of a component. Like whereas in C or C++, it will be like a .exe. It's a final component that you create and give it to anyone to execute it. So here also that we call it as like a .NET assembly. But here's two parts. Either it can be a .exe file or it can be a .dll file. So what is the difference between these two .dll and .exe? So .exe can run on its own, but .dll cannot run on its own, but it has to have something else to execute it. .dll usually it forms like a class library or it's like an API .dll. But whereas in exe is the starting point or for our invocation of the program. So an assembly is a collection of types and resources that forms a logical unit of functionality. So a program means what is? A program is like a functionality that you are going to achieve some objective. So basically some calculation program. Okay, the functionality, the calculation functionality you are providing. So what does it contain? It contains some kind of variables or some kind of data, whether it's integer two variables and again the sum of two integers will be another variable. So all these kind of forms is like a types, right? So all types in .NET framework must exist in assemblies. If the common language runtime does not support types outside of assembly. So whatever that you write, whatever the data types that you create, whatever the methods that you write, that all has to be a part of assembly only. Either it has to be a part of .dll or it has to be contained in .exe only. So apart from these two things, you cannot have anything else also in .NET area. So each time you create a Microsoft Windows application, Windows service or class library or other application using VB.NET or C#, right? You are building a single assembly only. So that assembly, each assembly is stored as an .exe or .dll. So whatever that you create it will be like a .dll or .exe. So the .NET framework uses assembly as a fundamental unit for several purposes. So let us say you have created a program and you need to give that program or the functionality to someone. In what form that you can give? You can give either DLL or a .exe only. So that is how that you deliver your work to any client or any company. So the Dotnet framework uses assemblies like as it's a different. So what it is? So how you need to protect, how you need to secure, right? How you need to protect yourself from someone using your program. So that all comes in this security part of the assembly. So again, security. So how you can secure your assembly, right? It's not like okay, I have created, but if I give it to somebody and if they are using without your knowledge, right? So it's not worth for your work, right? So in that way, how you can protect your work, how you can earn money for your work. Right? So an assembly is the unit at which security permissions are requested and granted. So you can give the permissions at the assembly level only. Right? So you can give permissions only for the CXE or for this DLL. Right? So assemblies are also the level at which you establish identity and trust. So how you can protect it? So there are there are two ways that you can protect your assembly. So basically the .NET framework provides two mechanisms for this level of assembly security. One is by using strong names and another one is signcode.exe. There is one tool called signcode.exe with which you can protect your DLLs or EXs. So you can also manage security by specifying the level of trust for code from a particular site or zone. So in the assembly also, right, you can protect your code at the assembly level, but at the same time, if you are having 10, 15 classes in your assembly, you can even protect your code at the class level also. So that is called we call it as a code access security. So that is something we will discuss maybe in the next two subsequent classes, that is called CAS. So here we will mostly concentrate on the assembly level security. So here signing an assembly with a strong name adds public key encryption to the assembly. This ensures the name uniqueness and prevents substituting another assembly with the same name for the assembly that you provided. So here you can even you can sign an assembly with a strong name key. So you can generate a strong name keys by using a small tool provided by Microsoft called snk.exe. That is called some strong name .exe. It will generate a keys like .snk files it will generate. So by associating this SNK file with the assembly, right, you can sign the assembly with that public key. So, and if you are, so let us say how you will protect it. So when you are delivering this DLL, right, to someone, you need to provide the private key to the customer. So with that private key, the customer can use your DLL. So when a request comes to the CLR for this DLL, then the CLR will authenticate this DLL by using the private key that is coming from the customer. So that is how your security channel will establish between the customer and your piece of assembly or DLL or executable. So that is one way of protecting your assembly and signing the assembly. There is another way called the signcode.exe tool. This uses a digital certificate for signing your assembly. This allows users of the assembly to verify the identity of the assembly's developer by using a public or private trust hierarchy. So you can choose either a strong names or signcode.exe or both also if you want to protect very securely for your assembly. So again, here I am saying that the common language runtime also uses internal hashing information in conjunction with the strong names and sign code to verify that the assembly being loaded has not been altered after it was built. So once you sign your assembly, nobody can tamper your assembly by pushing something into your assembly maliciously or by opening that assembly and creating something else after that. So that is how you can protect your assemblies from someone who is using that. So again, what is that? There is something else called the type identity. So the identity of your type depends on the assembly where that type is defined. So let us say you have declared so many types. Okay, you have declared your own classes, your own data types in the assembly, right? But how somebody can use that? So if you define a type named data store in one assembly and a type named data store in another assembly, so the .NET framework can tell them apart because there are two in different assemblies. So unless you clearly specify your assembly name with that data type, right? So .NET will tell you that okay, there is a name data type name conflicts that exist that saying that okay, data store is present in this assembly and data store is present in the another assembly. So in order to avoid that naming conflicts, right? So you need to fully qualify your data type when you are referencing particular data type in one assembly. So but in the same assembly, you cannot define two variables with same name. So that's not possible in the same assembly. So that is what the type identity. You need to basically give the full qualification with the assembly name to your data type in order to reference a particular data type from that assembly. So this is only in case if you have the same data type variable name in two assemblies and if you are referring that to two assemblies in your program. So what is the reference scope? So this assembly actually comes with when we were discussing right here in this diagram metadata, right? So what does this metadata contains? So when you are saying this particular after compilation, what is the resultant of compilation of your source code is assembly, either it's a DLL or executable. So that DLL contains intermediate language and metadata. What this metadata contains? So what is this metadata contains here is two things. The metadata contains your data, your types, whatever the classes or objects that you write it. And that metadata contains another thing called references, whatever the DLLs that you refer from outside of your program, right? So, and what it depends on, what your program depends on which DLL was found, right? So that these all the things that will contain in the reference scope in the metadata. So what is versioning for assembly? So it has the version 128-bit version number. It represents in the form like a major dot minor dot build dot revision. So each number can be like a 3 digits, like up to 255.255.255.255. So that forms as like a 128-bit version number. So for example, like in an assembly might have the version number like 3.5.0. 126. It's like a IP address, your IP address kind of thing. Right? So, 1 minute. So, let's say, okay, you have written one program and you have created that as a DLL. In that program, you have written some kind of calculation. Sorry, if someone want to speak in. Okay, Shekhar, do you have anything, Shekhar? Okay. Okay. So let us say you have written one interest calculation program, right? So there are some calculations that are already done in your program, right? And you have delivered that to the customer. So tomorrow, so because of some new requirements, you need to change that calculation. Shekhar, do you have anything to speak?
No, actually, my mission got restarted
Okay.
few minutes back. Can you go back quickly 1 or 2 slides back, please?
Sorry? Yeah.
It is because of my Java
Okay.
runtime something got restarted automatically.
Yeah, we'll go through at the end of the session, Shekhar.
Yeah.
Okay? Okay. Yeah. Please, you can go on mute. Yeah. Okay. Thank you. Thank you. Okay. Yeah, you have written some interest calculation program and you have delivered that to the customer in the form of a DLL, right? So tomorrow you will get a new requirement to calculate the interest, right? For that you need to change the same program, same method, right? Because whatever the code or whatever the DLL that you have already delivered, it's being used by so many other programs. So if you deliver this in again a new method or a new DLL, right? So the other people who are already being used this DLL have to rewrite their code. So in that case, in order to avoid that one, right? So if you give the same thing in your DLL, same DLL with the same name, right? So if you develop and deploy it, right? So you can overwrite it. But at the same time, let us say 3 or 4 people are consuming your first DLL, but not all the people want this new functionality. So only few people want this new functionality. Let us say 2 people want this new functionality and 2 people still want to use the old functionality. So how this can be achieved? So and you don't want the other 2 people who want the new functionality, they don't want to rewrite the code to use your new method or new DLL. So in that way, how you will achieve it? So how you will achieve it? You will just write the same program with the same name and same method name, but with a different functionality or different logic. But what you need to do is you just have to change the version number of this DLL. Instead of it will be like 350126. We'll just create the same DLL at the same location. So you can very well deploy the same DLL with the same name with a different version in .NET. So in that, what you will do is the other 2 people who want the new functionality, right? When they are accessing, you will just redirect their calls to this new version. So that is what is called earlier in the COM world, right? In the component object model in the COM DCOM world, it was very difficult to achieve this kind of functionality without disturbing the existing consumers of this DLLs. So that is how we call that as like a DLL hell. So that is how you achieve that functionality in .NET very easily. That is through versioning. It is possible. So we will talk about this. I will show you how you can create the DLL with the version number, how you will give the version number, how you can see that, what is called GAC, all those things we will talk in the next slide. So there is something called the assembly manifest. So each assembly contains an assembly manifest. It's again a set of metadata with information about the assembly. So what is the information about the assembly? Like assembly name and version, the culture or language, what the assembly supports, the public key, if it is like a signed assembly, it will have the public key, right? And a list of files in that assembly with hash information. So what are the information on the exported types and information on the referenced assemblies? This is all we call it as a manifest of the assembly, which contains the data about the assembly. So this all you can give it in the program itself. I will show you where we can give this information. You can even have your own name for the assembly. You can have your own version. Right? You can even change your culture or language for the assembly. Right? So these are all the things that you can do. So there are like two types of assemblies are there. So one we call it like a private assembly, and another one we call it like a shared assembly. So where exactly these private assemblies comes into the picture, where exactly the shared assemblies. So let us say you have one assembly, you have created a DLL, right? And if you think that, okay, only one person want to use this assembly, right? In that case, what you can do is you can so in that case, so and these lot of applications are deployed or put it in so many locations in your machine, right? And it's not good or it's not feasible to put your assembly in all the locations. So how you can achieve that? So rather you need to deploy this assembly at some common location wherein all the people comes to that common location and refer this assembly and they can use this. So what is that common location? So .NET comes up with a new concept called global assembly cache. So wherein this is like a centralized place for the assemblies to be located for the shared assembly. So whatever the assemblies that are located or that are deployed in this global assembly cache are called shared assemblies. So that means this assembly can be shared across the applications that are present in that machine. So that is called like a shared assembly. So, but there are some prerequisites if you want to deploy your assembly into the global assembly cache. So there are some prerequisites that you need to follow. What are the prerequisites? So by default, assemblies are private. So you are just creating the assemblies, and by default that is formed as a private assembly. And the types contained within the types, like classes or variables that you declared, are only available to the applications in the same directory as the assembly. Yeah, where you are deploying this assembly, whatever the application that are deployed in the same location, to that application only these types are available. But if there is any other application which they want to use the assembly from this location, they cannot use it unless you deploy that assembly in the global assembly cache. So, but every computer with the .NET framework installed also has a global assembly cache containing assemblies that are designed to be shared by multiple applications. So, yeah, there are like three ways to add an assembly to the GAC. So, you can directly drag and drop the particular assembly from one location to the global assembly cache, or you can use a tool called GAC util, that is called gacutil.exe, or you can install that particular assembly using the Windows installer also. But if you want to deploy any any assembly into the GAT, you need to sign that assembly before deploying that into the GAT. So then only it will become like a shared assembly. Then only you can say that okay, my assembly is protected. So now in most cases, you should plan to install assemblies to the GAT on end user computers by using the Windows installer only. Yeah. So what we will do is, let us say if you are moving one assembly from the test environment to the production environment. So there you will not have any liberty of dragging and dropping from one location to the other location. So all you have to do is you need to package this assembly with so many other assemblies also, right? Then you can deploy all these assemblies together by using a tool called the Windows installer or GAT util. So these two, the GAT util and the drag and drop method, only we will use when you are deploying the applications or when you are using that in the test environment. But when you want to move to the production environment, so you use the Windows installer only to move your assemblies. So this is all about the assemblies, and we will see how you can create the assembly and how you can use that assembly in the subsequent classes. Today I will show you the basic exe as an assembly. So after this, okay. So here there is something, one more thing that we need to talk about is like a .NET namespaces. So .NET namespaces, it's like a grouping of type names. So you are declaring a lot of classes, lot of variables, right? So you want to group them. So you don't want to create in a random manner. Just create it, right? So you want to group it. Okay, you want to group it based on some requirement, some functionality, or some domain, right? Something like that, or some organization or some scope. So based on that, some kind of scope, you need to group all your types, all your classes that you are declaring in your assembly. So in that way, this namespaces is the one that allows you to group all your types into logical groups. So a namespace can contain both other namespaces and types as well. So you can have a nested namespaces as well. The full name of a type includes the combination of namespaces that contain that type. So you have declared a type in one namespace. So if you want to use that particular type, so you need to pre-qualify that type with the namespace name. So that's so again here, if you think about the assemblies and the namespaces, it's two different ways actually. So the assemblies form is a fundamental unit of execution parts. Here the namespaces is a fundamental unit of logical code grouping. That is like a physical code grouping. Here it is like a logical code grouping, the namespaces. So if you see the my slide right here, I just put some kind of sample namespace how you can declare it. So here namespace, the name of the namespace is sample namespace. In that we have different types like a class, interface, struct, enumeration. We have declared a delegate. Along with all other these types, I have declared another namespace in the namespace, which we call it as like a nested namespace. So, but the namespace, that the name is sample namespace dot nested. So in that namespace again I have another type called class, some sample class name I put. So this is how you can group all your. So these are all forms as a one group actually. These class, interface, struct, enum. These all types of forms one group called sample namespace. So you can declare any name. You can put any name for your namespaces. So this is about namespaces. So now we will talk about the framework class library. So what is the framework class library? So it's a framework class library that comes as part of .NET framework. So which is a container of so many APIs or it contains a library of classes, interfaces, like value types. So that provides a different kind of functionality which you can use it to read files, write to the files, or read from the consoles, right? You can create Windows application, basic functionality, the button, the what are the text boxes, all those things that comes into the .NET Framework class library. So this includes types that perform the following functions, like, okay, as I was telling, it represents base data types and exceptions. It encapsulates data structure, performs I/O, access information about loaded types. So it invokes .NET Framework security checks. So provides data access with client-side GUI and server-controlled client-side GUI. So whatever the function or whatever the API that you use in .NET, right? It comes with the framework class library. So, for example, there is like more than 100 namespaces that are available in framework class library. I just put three namespaces for the most commonly used namespaces. The one namespace that we most commonly use is system. It contains like fundamental types and classes that commonly used for value and reference data types, events, event handlers, interfaces, attributes, processing exceptions. So all these things. There is system.io that we use this namespace for reading and writing on data and streams and files like that. So system.windows.forms is the namespace which we use for creating the Windows applications. So these are the namespaces, and these are the class library that we use in the .NET. So with this one, we have completed this overview of .NET by discussing about CLR, the common type specification, the MSIL, and the compilation model, how the .NET compiles code. And we discussed about the .NET assembly, namespaces, and the framework class library. So now we move to the next section in our agenda about the Visual Studio. So anybody has any questions so far? Okay. So what is Visual Studio .NET and what is .NET? Sorry, we are calling it both .NET Framework and Visual Studio .NET. So .NET Framework is like a runtime only. It gives as a runtime for executing the application that was developed in .NET. So, but what is this Visual Studio 2008? So Visual Studio 2008 is an integrated development environment that was provided by Microsoft, which we can use to develop the different types of applications like Windows Forms, websites, web applications, web services, right? So together with managed code for all platforms supported by Microsoft Windows, Windows Mobile, so Windows CE, and all these things. So this is like basically like an editor actually. It's like it's not just like an editor actually. It provides a lot of other functionalities, much more beyond just editing the code or writing the code. So you can debug using this environment, right? You can create XML, you can write the XSL applications, right? You can design the Windows Forms. All those things you can create it using this Visual Studio 2008. So what are these prerequisites for Visual Studio 2008 and what do you need for this Visual Studio? So you need like either Windows XP Service Pack 2 or above. So when it comes for the server environments, you need Windows Server 2003 SP1 or above, or Windows Server 2003 Release 2 or above. Or you can have, if it is personal edition, you can have Windows Vista or Windows 7. Again, server edition, you can have Windows Server 2008 also. So these are the prerequisites, like the platform, the operating system requisites for Visual Studio 2008. And the hardware requirements are you need to have a minimum like 1.6 gigahertz CPU or like 384 RAM, 1024 by 768 display, the resolution. So these are the like things that you need it for installing this Visual Studio 2008. So we have different types of editions. So here we need to observe differently. Visual Studio 2008 is a version. 2008, 2010, and 2011. These are all versions, but we have a different editions which exist in each version. So we have a different edition like Express editions, Standard, Professional editions, right? And you have something like Architecture, Database edition, Development editions, Test editions. All these things are there. So except this Visual Studio 2008 Express, all other editions are paid editions only. But you can get this Visual Studio 2008 Express edition for free from Microsoft site. So you can very well go ahead and download that edition, and you can use that for practicing your labs or whatever that you can create all the applications using this Visual Studio 2008 Express. So you don't have any restrictions there actually. So okay, with this I think yeah, we have completed our theoretical session today, and I am going to demonstrate a small Hello World application wherein I will be demonstrating what is the exe and how the assembly manifest looks, right? So how you can write the code using Visual Studio, so all these things. So anybody has any questions so far? Yes, Satyajit, yes, sir. You can install. There is a different edition for that also. Actually, you can very well install it on Mac.
Raja,
Yeah, tell me, Sekar.
yeah, are you able to share this the 15 slides, the presentation?
Yes, yes. You can contact Prasad or Prabhat for that, so they would be able to provide you.
Okay, that will be it.
Okay, okay. So now I am going to use this Visual Studio 2000 Express. This is like a C# 2010 Express. So now I am going to. Okay. So this is the Visual Studio 2010 Express. It looks like. So I have just downloaded it, and it's a very well free that you can get it from the Microsoft. So this is how it looks like. So now I am going to create one console application, very basic console application which will display Hello World. So now I am going to create it on. I'm going to click on File, New Project. I'm going to take it. Okay, here you see, right, there are different types of applications you can create it by using the same IDE. So one is Windows Forms application, and another one is WPF application, that is like Windows Presentation Foundation. Console application, you can create class library, WPF browser application, or you can create empty project also. So now we are going to create the console application, and we will change it to the name demo console. Right now, I'm going to click OK. So here, if you see this IDE, right, there are different things that you need to observe here. So I just ping this Windows. So this we call it as like a solution explorer. So when I create this project called demo console, so by default it comes with a file called program.cs, whichever that I have opened it is called programs.cs, and it will give you some basic, it will add already references, some basic references. So if you see these, right, these are the different assemblies that comes by default with Microsoft. Microsoft.C#, data set extension, XML.link, all these things. And if you open that another folder called properties, there is another file called assembly.info.cs. I'm opening that file by double clicking that, right? Now let us see what this file contains. So in this file, if you see this using keyword, using is a keyword actually, right? This is another system.reflection. This system.reflection, what is this? System.reflection is a namespace actually. So using means it's like a import keyword in C or C++. So that means you are just importing that particular namespace into your program to use the types that are available in that particular namespace. So like in that same way, the .NET here, right, we are importing three namespaces like system.reflection, system.runtime.compiler services, system.runtime.interop services. What is this is what I am talking about when I am talking about the assembly manifest. Right? So this is what is called assembly manifest, assembly info.cs. So what it has? So it has got a property called assembly title. This is like a demo console. That is the project name that we put it. That will come automatically as a assembly title. If you want to change that title, you can very well go and change this title also. But generally as a best practice, we keep the assembly name and the project name similar in order not to confuse between assembly names and the project names. So we can give the assembly descriptions. So this is created for demonstration. You can give the assembly configuration, anything that you can give. Just sample configuration you can say. So you can put any name here. So copyright, product, all these things you can give anything. You can even give the trademark. You can give the culture, what culture that you want to put. Is it like English or Japanese, Chinese, or anything that you can give. So of all these things, right, here something like the COM visible. This is some property that you need to pay attention to it. So if you just read the comment that is available there, setting COM visible to false makes the types in the assembly not visible to COM components. If you need to access a type in this assembly from COM, so let us say you have a VB language or VC++ language before .NET. So if they want to use your assembly in their program, so unless you specify this as a true, they cannot use it. So that means COM or COM plus and all, right, it comes in the VB or VC++ only. So unless you specify this particular property as true, they cannot use this assembly. So by default, we make it as false only, because when you make it as true, it again generates a lot of other metadata or something else actually, which will reduce your performance a little bit. So by default, it will create a 32-bit GUID, which is unique for this assembly. So by default, it comes here when you create a project. This is like an assembly GUID, which is for the identification of your assembly when you expose it to COM. Otherwise, it will not be useful at all. So what we were talking about, the assembly version, right? So first one is major and the minor, build, and fourth one is revision number. So because since this is the first time that it is creating, it will just give you the 1.0.0. So if you want to change it, you can go ahead and change it. So that is, one is assembly version, another one is called assembly file version. So there are two things actually. Assembly file version is different from the assembly version. So in general, right, what we need to concerned about is assembly versions only. So we don't need to bother about assembly file versions. You can just very well leave that assembly file versions like that. With multiple assembly versions, you can have only one file version also. So that is how. So for any file, you will have a version. So that is what is like here. It's also assembly file version. So you don't need to bother about that assembly file version. So this is what we call it as an assembly manifest. So we'll go to the next file called program.cs, which is the main program where we write the code actually. So if you see it here, right, by default again, so the Visual Studio, it gives the four basic namespaces. It's importing four basic namespaces already, and it has created a namespace called the project name, whatever the project name that we have given, demo console. Or here also, if you want to change the namespace, you can change it, or you can keep the namespace similar to the project name, you can keep it. So, and it has created by default one class called program, and in that one it has created a method called main, static void main method. So this is where we can write our program, and this is what the starting point for our invocation of our program. So here we can just go ahead and write something called console.writeLine. We'll just write hello. World. So what these two lines does, this console.writeLine.hello world. So what it tells is, it will write a string called hello world to the command window, to the DOS command window, or to the console. And the second line waits for the user input on the DOS command window. It will just write that hello world, and the second line is for the reading some input from the consumer. So from the user. So that is what we write it as a console.readLine. So this is how we write the program, and now we are going to build the this program. So we have something called the build solution. Now we are going to click the build solution. So now we got this build solution. So if you see these three things, right? So the solution explorer has three icons. It will tell you the properties of the solution. Here this is a, you can see the properties of the solution by clicking these properties. Here it will tell you all the, what is the assembly name is going to be. It is demo console. If you want, you can change the assembly name here also. Or you can change in the manifest also. It will give you what is the default namespace of this assembly. And it will tell you what is the target framework. So here we have a different versions for the .NET framework. We have .NET Framework 2.0, 3.0, 3.5, something like 3.5 client profile, 4 client profile. So by default, since this is the Visual Studio 2010 Express, right? So that is why by default it is choosing the .NET Framework 4 client profile. So if it is a 2008 version, it will by default it will choose 3.5. So it is saying the current project must be saved before changing the target framework. So we have not saved our project actually. Now we are going to save our project. So by default I am just going to save at my training. So demo console I am going to save as a project name. Now I am going to save it. So after changing, I am going to change the .NET Framework 3.5. So here it will ask, okay, are you sure you want to change the target framework for this project? So basically it's saying that any unsaved changes within this project will be automatically saved when I am going to save it. Okay. So now I changed the target framework. So now I click that and it is target. So there is something called output type. So there are different types of output. So one is Windows application, another one is console application, the third one is class library. So though you have selected a console application when you are creating a project, right? So later if you change your mind to move to the Windows application or class library, so this is the place where you can go and change your output type. So, but right now for the purpose of our demonstration, we will keep that as a console application only. So if you click it here again, it will give you some more information about the assembly. So here it will give you the demo console, the title, whatever that we have given there, right? The demo in the assembly manifest, it is coming here actually, demo 1, 2, 3. I'm just going to delete it. So whatever the description that we have given there, it is coming here. Here also you can change it if you want. The company, best key solution, product, copyright, right? Trademark, you can give assembly version, file version, GUID, neutral language, or you can change any language, so many languages that are available. Right? Here it will give you the make assembly composite. So I'm just going to say, okay, whatever that there you are editing in that assembly info.cs file, so you can do the same thing in this window also. I'm just going to click OK. Right? So here there is another different types of properties like build. So there is like something general conditional compilation symbols. If you want to give any symbols that you can do, it will tell you the output path. So many things. Treat warnings as errors. You can tell that as all or null. Right? So these are like when we are progressing through our training, right? So wherever it is appropriate, I will explain these different types of properties here. Here it is a pre-build event, debug. So there are settings, reference paths, all those things are there, right? So this is the thing, and now I'm going to click this here, right? So as I save this project, now I want to run this project. If I want to run this project, I just have to click this button here. If you are seeing that, right? One button, run button. This is called run button. it's like a green color triangle. And clicking this one, single click. Now this project will rebuild again, right? And it will execute it in one step. But earlier when we click the build, it will just build it, but it didn't execute it. So it has executed our application, our program. Now it has displayed hello world as per the first line. And in the second line, what it is trying is the control is waiting for the user input because we told that read line. So read line means it can be any input from the consumer, from the user. So now I am just going to click the enter button so that it will just take that output. So after this console.readline, since we have not written any code, it just took that input and it exited the program. So that is how it executes the program. So now we will go and see our executable, where it is. Now I am going to the Windows Explorer and see where my program is. See here I have created a program called demo console. So here it is present. Right? This is where my solution, all those things are available. Now I am going to open this. Right? So this is where all my files, program.cs, right? And in the properties folder, assemblyinfo.cs, all these things are there. Now I am going to see, as we are telling that, okay, it will create exes, it will create DLL, all these things. Oh, let me share this Windows. I'm not.
The window is not visible.
Yeah, I'm going to share that. Yes. Okay, right. So this is where my demo console application has been created, right? This is where my solution file, all these things are present. Now I'm going to open this. This is where all my files are present, program.cs. Since it is a CS project, C# project, it created a CS project file, right? In the property, it is the assemblyinfo.cs file is also there, right? So now where is my assembly? We have been talking about the assembly.exe, .dll, all these things. Now where is my assembly? The assembly is created, if you see these properties, right? You see these properties. If you see these properties in the build, we told that the output part of the assembly is bin release. So this bin release is a relative part for this project. So when I am in my path, right, this is the project. This bin release is the relative part from this project path. So that is the output path that we have specified here. So if you want, you can change this output path also. So now I am going to be called bin and release. So this is where my exe is present. So this is what we have been talking about the assembly, all these things, right? If you see this, right, whenever I just selected this file, if you see this in the bottom status bar, description, it is giving demo console 123, right? Company best key solution Inc. It is being file version, and it is telling date created at the same some time, right? And the size it is giving 5K. So we can even see that thing by right clicking on this file and go to the properties. So you can go to the properties, you can go to this version tab, right? Here also you can read all these things. The assembly version, it is saying 1.0.0. Comments, this is created for demonstration. Company, file version, internal name, that is called demo console.exe. language is, we just select a neutral. The original file name, the product name is demo console, the product version is 1.0. So these are the different ways of you are seeing this. This is after creating the assembly. So let us say you got one assembly from some third party product or some company, right? So wherein you want to see these properties of this assembly, right? So you don't have access to the assembly info.ts. You cannot open that assembly info.ts file, right? But then how do you check that? So this is the way that you can check it. You will get the assembly. You can go right click and go to the version tab. You can see, you can read all the properties of that particular assembly. So that is how you can read the assemblies, and you can generate the assembly of type .exe. So tomorrow we will see this, how you can create the .dll assemblies, that is called as class library. So this is, with this demonstration, we can conclude this today's training, right? So tomorrow we will continue on the, as per our, the course curriculum. So if anybody has any doubts, so we can discuss about that. So anybody has any doubts, or how is it like? Are we going too fast, or are we okay, or if you want to move slowly, or if you want to move fast? So if you can tell us, so that we can adjust in the tomorrow's training. Yes, there was a question from Secret Derso. So he is asking that, okay, are we going to write any code tomorrow? Yes, we are going to write, we are going to demonstrate about the conditional statements like if, else, for each, for loop, all those things we are going to demonstrate tomorrow. So, and we are going to give the lab also on the same conditional statements tomorrow.
Hello?
Uh,
Hello?
yes.
Oh, yes, you're breaking up.
Hello.
You were speaking, I couldn't hear you. You were breaking up. I have a question.
Oh, okay.
Do we have to have the software installed by tomorrow? Are we going to practice any codes tomorrow, or is it just going to be a lecture?
Yeah, if you can install it by tomorrow, that would be great. But otherwise, what we can do is we can demonstrate it tomorrow, and I can give you the labs. So you can, after our class tomorrow, you can very well practice that.
Oh, like you mean you're going to give us like a sample code to practice, or?
Yes, that's correct. I can send this project to everybody, and
I see. Okay, so is it going to be, which language are we going to be using? Is it ASP or is it like C#?
C#. We are going to use C#.
Oh, is it going to be like, I have no C# background, is it going to be a new language to pick up, or is it?
Do you have you have any VB experience?
Yes.
Okay, yeah, you can even very well write the same code in VB.NET also. It's
Okay,
almost
so it's going to be
same
C#
only.
and ASP, or is it just going to be because I called somebody at your office and they told me that it's going to be ASP also, so.
Yeah, we are going to discuss in the ASP also in the subsequent classes, because so far we have not completed the basics, right?
Mm-hmm.
So that's why we are discussing today. Tomorrow we are going to discuss about the basic conditional statement, data types, all those things. So there are classes where we will discuss about ASP also.
I see. All right, thanks.
So Ravindra, this is Anshul again.
Yeah, Anshul, yeah.
like I asked in the beginning, these programs seems to be like, okay when you're learning a new language, but most of us, I don't know, I had to speak about others, but at the end of this phase, I feel we expect to be like working on some kind of real project, real like business project. Do you have any inputs around that? Or like,
Yes, actually we have dedicated one 2.5 hour class for the project itself. So wherein we are going to show the creating some web pages, right? So how we can deploy that, so how we can create the project and how we can work on that. There is a class for that, Anshu.
my main concern is like, would that be like a typical real life project, or would it just be like a demo project to show on how things are handled now? Because demo projects are usually like the high complexity of what a real life project would look like. They don't really go into those kind of details.
See, see, if it is okay, if it is see, as far as me, I don't see any big difference between the like real life projects or demo projects, right? As long as that has all the required elements, like see, even in the in the real time projects also, what it will be. So it all has the things. Okay, the project, what in my opinion is, it has to cover what we have discussed in the classes, right?
Yeah.
So we will use all the topics that we have covered. Okay, if you discuss about some text box or button control, right? So we will cover all these things in the project, so that we will create one project which will achieve one objective, one set objective.
Okay.
So if you're taking that like a real life project, right? Okay, if you take some financial industry project, right? So it contains a lot of other things also. There is so many systems are involved, so many things are there. What we'll take is, we'll take one small piece in that real life only. Let us say banking system, right? We'll just take one web form wherein that user comes and gives his information for creating the account, right? That's also a real life only, but for demonstration also, that will be very easy for everybody to understand. So which covers all the concepts, like, okay, you are creating one information and it will go and store in the database, right? So, and again, how you fetch that from the database, so how you modify it, so how you delete the account, how you add the account, how you modify the account, right? So all these kind of things we will cover actually. So we will write one web service where you can use that web service to create the account. Definitely it will cover all the aspects of the things here.
That's what I was trying to get to, that at least one project where we cover all the aspects of features, like video describing.
That's correct, and yeah, definitely we will be covering that. Anybody has anything? Okay, if nobody has anything, then we can conclude the training for today. And if possible, you can try to install this, whatever that I told, the Visual Studio Express edition in your machines by tomorrow. So that would be easy for you to do some labs also.
Is it the same time tomorrow, Raja?
Yes, same time, Shekhar. Any concerns, Shekhar?
No. Like except
Okay.
that I'm looking for that material because of
Oh,
price booking.
okay, okay. Yeah, you can contact Prasad or Prabhat for that, right? So they would be able to provide you that. Okay then. Yeah. So then, okay. Thank you everyone. Thank you for attending that, and we'll see you tomorrow at the same time.